All right, this is going to be self-check 2.3. There were 4 questions, so give yourself 8 minutes to solve all 4 of them. All right, so this is going to be problem number 1. Currently, I have 1 student, Joy, in the class. Say hi, Joy.
Hi.
All right, so number 1, we have this problem. So, Joy, what'd you get?
I got
E. E? All right, limit does not exist. Is that because you put h in and you got 0?
Yeah.
Yeah, so you're right in thinking that, and that's why they put that there for E. But for this one, whenever I have the limit as h approaches 0, so when I see this guy, I need to be thinking, ooh, hot box. H approaches 0, always think hot box. So our hot box is the term that has the plus h, so that's our box, our hot box. And then do you remember what we do with our hot box, Joy?
No.
So we have to figure out what our C is for our hot box. C is the thing being added to H. So our C is what?
3 pi over 2.
3 pi over 2, perfect. And then I do what with everything inside of the parentheses? Yeah, so scribble it out, turn it into an x. So that means that my function that I'm looking for is what?
Oh, cos x
Cosine of x.
minus cosine of 3.
Oh yeah, don't worry about that. Hotbox is only dealing with what's inside the box. So that means f prime of x is equal to what?
Negative sign.
Negative sine of x. And therefore f prime of our c is f prime of 3 pi over 2. And that is equal to what?
Negative sign.
3 pi over 2, yep. Well done. And then we have to figure out where negative sine of 3 pi over 2 lives. So let's make our coordinate plane. So that's 0. Or do you know where it is, first of all?
It's in the first. No, it's in the third quadrant.
Third quadrant down here somewhere?
Yeah.
All right. So we have to be careful. I'll go ahead and label this and maybe it'll make it a little bit clearer. So this is going to be pi over 2 right here. This is going to be 2 pi over 2. And this is going to be 3 pi over 2. Yeah, so pi over 2 is every 90 degrees. So 3 of those 90 degrees is 270 degrees. So we're looking for a point down here.
I thought it was opposite because it's negative sign.
So you can think about it that way. So negative sign would be up here, I guess. I'm gonna deal with the negative later, and I'm just gonna take sine of 3 pi over 2 right now. But you can do it that way too, because that is a perfectly valid way of doing it. And I'll talk about that really quickly after I solve it this way. So what is sine of 3 pi over 2?
Negative 1.
Yep. So I'm gonna write that down in a different color for our notes. Sine of 3 pi over 2 is equal to negative 1, because sine is asking for the x coordinate or the y coordinate.
Oh, the y.
The y coordinate, exactly. And then cosine is asking for the x coordinate. So the y coordinate is negative 1, because remember, trigonomic functions are always asking about a unit circle meaning a radius of 1. So the radius is 1, it comes down to negative 1. But now that I have the negative, a double negative makes it a positive. So a negative 1 is, so my final answer is a positive 1. So equals 1 from here. So my final answer is A. But I want to talk about Joy's method because that works too. If you want to go negative, that means you're going in reverse order. So instead of going this way and saying, okay, well, this is pi over 2, you would say, okay, I'm going to go this way. So this is going to be negative pi over 2, negative 2 pi over 2, and negative 3 pi over 2, in which case you'll still get a distance of 1, taking into account the negative. So A is the correct answer. All right, questions on 1, Joy? You got it? All right, on to number 2. Numero dos. So if this is our function, then what is f prime of that function? So what was the answer that you got?
Should I rather not say?
Okay, and then let's talk about what you think about when you saw this function.
I was supposed to put 3x over x. Then that's neither of the answers.
3x over x. Oh, okay. So this is actually our advanced derivative, so it has to be one of those rules to remember, like quotient rule, stuff like that. Do you see it in here? There are two functions. There's two x's. When I see two x's, I'm suspicious and I say, oh, this is multiplying two functions. Multiplying two functions is called the what rule? Starts with a P?
Product.
Yeah, product rule. Product rule. And I'll repeat that again. Make sure that when you see two x's, you think product rule. And product rule states what? F prime of one function times the second function is equal to, do you remember the formula, Joy?
Second function. Oh, you know, the first function, prime.
So it's
and
easy.
then the prime of the second function.
Yeah, I'm going to say d2 instead of 2 prime. 1 d2 plus, not a minus, minus is only for quotient rule, plus 2d1. And that's the guy that we need to memorize. All right, so our first function is 3x, second function is natural log of x. So plugging that in, and we'll go through this together. You want to just shout out what to write down?
So it's just log of x times 3.
Can you just fill in the formula? The 3x is like the first function, so 1 would be 3x.
Oh, 3x times 1 over x.
Times 1 over x. Yep. Plus
Natural
log of x.
times 3.
Perfect, yeah. And then I think you had it simplified already. So this is 3 plus 3 natural log of x. Because x's cancel out, I'll go ahead and do that with a... I'll just leave it like this. You guys can see x's cancel out. And is that an answer? Oh, it's not an answer. Because you need to know rules of natural logarithms. So most people would say, oh, it looks kind of similar to c. But it's not. It's 3 divided by x, and that's not correct. So do you see what you're supposed to do?
A.
It is a, yeah. And I'm thinking you're familiar with the rule. If you have a natural log of b is equal to, and then you can bring the a up, and you can say this is equal to natural log of b to the power of a. And what we did in this case is going to be the 3 came up here to be natural log of x cubed. So that's where the x cubed came from. Perfect. All right, on to number 3. All right, do you want to say what you got, or just be anonymous? No idea. Okay. So what is dy dx? What does this guy mean?
Derivative of y.
Yeah. So this is saying what is y prime? What is the derivative of y exactly? So this is another advanced derivative. So what is the name of the rule that we're using?
Quotient.
Quotient. Yeah. All right. Do you remember what the rule states? If I take
Same thing, but with a negative.
yeah, and can we do the, we'll say if I have, if f, oh wait, what's a better way to simplify this rule? High and low, the derivative of this, so, if f of x is equal to high over low, then f prime of x is equal to low d high minus high d, I should do it a little times there, high times d low, and it's not a w, and then all this over what?
Over low squared.
Yeah, all over low squared or low. So low d high d low over low. All right, let's fill that in. So just, I know that you can simplify it really quickly. Can you just fill it in for us in the video?
Oh.
So what's our low?
It's 1 minus x.
Oh, that's high. Careful. Low is the denominator.
X minus 1.
Yep, x minus 1 times.
Times 1.
careful here. So
Negative one?
negative 1, yeah.
Oh god.
And let me explain that for the video. So Joy is seeing that this is a minus x over here. So if I take the derivative of the top, it's going to be 0 minus 1, which is negative 1. All right, thank you. And then continue on.
1 minus x times 1.
1 minus x times 1. All of this divided by...
X minus 1 squared.
Exactly, yep. Cool. And then I just need to simplify this a little bit until I get it into one of these forms. So I'm going to come back over here and I'm going to say that's going to be, well, negative 1. That's going to change, I'm going to multiply that negative 1 into both of these terms. I'm going to distribute it. So I'll get a negative x plus 1 and then minus. And then this minus is going to be distributed into the 1 minus x. So it's going to be minus 1 plus x. And all of that is going to be divided by x minus 1 squared. So right away I can see it's either going to be b or e. And because e has the x minus 1 squared on the bottom, and it might be b because the numerator might be 0. So the x and negative x and x cancel out. The 1 and 1 or negative 1 cancel out. So we have 0 over x minus 1 quantity squared, and we find our answer. Answer was b. All right, you good, Joy? Or do you want some time to think about it?
I'm good.
You good? All right. On to number 4. Whoa. Okay, I swear that was the pen messing up. What is the slope of the line tangent to the graph of this one? You want to tell us what you got, or do you want to be anonymous again? Anonymous, okay. So, again, we have to be suspicious. We have 2 x's, so we're using quotient rule again. Quotient rule, and you already know this because you can rewind the video, but if I have f of x is equal to high over low, then f prime of x is equal to low d high minus high times d low all over low low. Okay, so filling into our equation, our low is x plus 1. Our d high is going to be e to the negative x times negative 1. Don't forget about dinner. And then I'm going to subtract. High is e to the negative x times low, or d low, sorry, times 1. All of this is going to be divided by low low. Oh, I was going to write low low. This is going to be x plus 1 quantity squared. Interesting that they don't have x plus 1 quantity squared in here for the denominator. We'll see what's happening here. So what do we have in the numerator? In the numerator we have, I'm going to, so right here in this guy, we have a negative e to the negative x. I'm going to distribute this negative e to the negative x into each of these terms. So I'm going to multiply that into here and that into here. So what do I get? I get a negative, and maybe this is not a good idea. Actually, I changed my mind. I can see ahead. I don't want to do that because I see that this is also an e to the negative x, or negative e to the negative x, so I can actually factor that out because it doesn't look like any of this has an e to the negative x. So what that means is I can, how am I going to do this? Man, I don't see how to get into any of these forms at the moment. X plus 1. Oh, at x equals 1. I did not see this. Okay. So we're subbing in 1 into x. So what we can do is we can just put that in right away. We don't have to simplify. We have our formula. Let's go ahead and plug it in. We get 1 plus 1, 2. Joy, fill in the rest for us. So this is going to be negative e to the negative 1. Keep going.
E to the negative 1.
Perfect. Divided by
4.
Yep, divided by 4. Cool, and that's because 1 plus 1 squared is 4. All right, so what do we have here? Simplify the numerator. We need to push this e in the denominator. We can see that e is in the denominator for all of these. So e into the denominator is going to be a what? maybe we need to simplify the numerator because we have a negative 2e to the negative 1, and we're going to subtract another e to the negative 1. So the numerator is going to become what, Joy?
Oh god.
This is like negative 2x minus x. This is essentially what it's saying right here.
Negative 3e.
Yeah, negative 3e
Use a power table.
to the negative 1. Yeah, exactly. And that simplifies to negative 3 over 4e, because I just moved the e into the denominator. So we're looking for a negative 3/4 e, or negative 3 over 4e, and we get b. Lots of simplifying there. So this is the reason that I say always simplify in my class, because multiple choice makes you simplify a lot. All right, questions for number 4? All right, that concludes the video. Stick around for 2.4. Please like and subscribe.